What we're going to focus on now is learning how to display and summarize quantitative data. Remember that quantitative variables are anything with units attached to them. So, for example, income is a quantitative variable because dollars is its units. But things like height and weight also have units attached to them, or time also has a units attached to it. It could be measured in seconds or minutes or years. So all of those are relevant variables here. To give you an example of this, I collected some data from a government agency on earthquake magnitudes. So this is for the year 1985. They've recorded every time that an earthquake happened, the month that it happened, its day, its location in terms of latitude and longitude, the state that it happened in, and then the magnitude of the earthquake. So the magnitude of the earthquake is a quantitative variable because it's measured on a Richter scale. And so that's what we're going to focus on learning how to display and describe it. Once we have our data, we can see that there's a large amount of it. And so it's best sort of to make a picture of the data so that we can easily see what's going on. The most frequently used displays are histograms, but we'll also go over dot plots and stem and leaf displays in this video and save the box plots for another video. So with histograms, what we do is we count up the number of observations that fall into each bin. So bins look much like a bar graph, but this is slightly different than a bar graph because we have control over the size of these bins, so the distance between one bin and the next. And these should all be of equal length. And then we just count up the number of earthquakes that fall within each category. So here we can count up the number of earthquakes that fall between 7.0 and 7.2, and it is almost 225 earthquakes. Now for the data set that I collected, we can also do this for the year 1985. And all I have to do is highlight that whole column and go to Insert. And remember that this is for bar charts, is for categorical variables. But since we're dealing with a quantitative variable, we want a histogram, which is slightly different. So when we click on this arrow, there's two different histograms that we could look at. The first one is just a regular histogram, and it puts our bins then in order of magnitude, and you can see that it automatically chooses the size of our bins for us. The other chart is a Pareto histogram, and here you can see that it puts the bins in order of magnitude so that the one that has the most earthquakes in it gets put first. So you can see that most earthquakes happens between 4.85 and 5.38. And then the next most frequent is put second. Right? So for now, let's just focus on our general histogram and try to describe that histogram. We can control again the size of these bins. If I right-click on this lower axis and format that axis, over here on the right, it shows that we can control the bin width. So Excel automatically chose for us a bin width of 0.53, but we can change this to whatever size that we want, and Excel will automatically count up the bin sizes for us. So I'll hit enter here, and you can see that we end up with only 4 bins then, and they're really, really big bins. Most earthquakes fall between 4.2 and 5.2, but we can also change the bin size to be really, really small. Let's say 0.1, and that will give us a bunch of really, really, really tiny bins. And so it's important to choose the right bin size so that you get a nice picture that describes the data well. A relative frequency histogram is similar to a regular histogram, except that on the y-axis we have the percents instead of the count data. So again, the percent is just in terms of the total. So each of these represent the percentage of earthquakes that fall between 5.0 and 5.2, and you can see that that percentage is really small. So what can go wrong? Well, as I pointed out earlier, that choosing the bin width is really important. If you choose a bin width that is too large, what you end up with is something that's really not very descriptive. So here it's saying that the price change is somewhere between -20 and +20, and that's a really big range of price changes. So it's not giving us much description or much information. Whereas if we choose a really tiny bin width, what we get is basically one observation in every bin and lots of gaps. And again, this isn't providing us much description about the data set either. So we want to choose a bin width that's somewhere between these two sizes. The next display is called a dot plot display, and much like a histogram, it just counts up the number of observations in each bin. The difference is that the bins are now put horizontally rather than vertically. So each dot here represents an observation. So this data set is looking at times that the winning horse run the Kentucky Derby for all the years that it's been raced. And you can see that most of the observations fall here within around the 2-minute mark, and then there's several that take around 160 seconds to win. The main difference between these two sets of data is that the distance of the race was changed in 1937. So all of these races were raced prior to 1937 when the distance was still 1.5 miles, and all of these races were ran when the track was only 1.25 miles. So you can imagine that the race would be faster if you don't have to travel as far. But again, each of these dots represents 1 year, 1 race of the Kentucky Derby. The last display we're going to look at is a stem and leaf display, and this is a lot like a dot plot display, except instead of dots, we put the actual number of the observation. So the stem is going to be our tens unit, and then the leaves are created by each single observation. So you can see the dot plot kind of looks like a leaf with these observations representing the leaf. So the example that I have for you for a stem and leaf display is past homework scores from other classes. So here is homework scores from another class, and you can see that I've hidden the student's name, and here's their gender as a categorical variable that I collected. And I'm just going to remove that from now because it's not relevant to displaying our quantitative variable. We're only going to display the homework scores, and you can see that I've already sorted it in order of magnitude from lowest to highest score, and you can see a bunch of students got 100 on it because they have an unlimited number of tries on the homework problems. And then the stem and leaf display is over here. So what I've done first is I've created the tens digit, so from 0 to 10, and that represents the first number here in all of it, all of the scores. So there's no scores that fall in the category 0 to 10, and so there's no observations in that leaf. From 10 to 20, there's 1 observation, and that's 18.2. So that's the tens, and then there's 1 observation, and you just put the last 2 digits there, 8.2, and then there's no more observations. There's nobody who scored between a 20 and a 40, so 20 and 30 are empty, and then in the 40s, there's one student that scored in the 40s, so again, you just put their last 2 digits as their observations. There's no 50s and 60s, which is why all that's blank, and then in the 70s, there's 1 observation. Again, it's just those last 2 digits. And then we start seeing more, and then you can see that there's 11 people that scored 100. So that's it for these 3 types of displays. Next time what we'll talk about is the shape and distribution of the histogram, and we'll spend more time on the box plot as well.